Hey guys, here is the solutions for the marble ramp worksheet. So we want qualitative graphs of your position versus time, velocity versus time, and a motion map, and then indicating whether the quantity is positive, negative, increasing, or decreasing. So for this first problem, we start with an initial position of 0. So we'll call that 0 down here. And the object will be moving to the right from 0 to 50 centimeters. So if we want to draw the motion map here, I'll call this most left point here 0. And this object starts with an initial velocity of 0, but then slowly begins to roll down the ramp. So as it rolls down the ramp, its velocity will gradually increase as it goes towards the bottom. And we can draw this motion map in this going to the right because we see that the marble is moving from left to right, which means that it has a positive velocity in this case. So because it has a positive velocity, we know that its position here is going from 0 to 50. Its position is increasing, and I'll just put an I for increasing. The velocity of this object is moving to the right, so its velocity is positive and it is increasing. The acceleration, if we look at the motion map, the arrows are getting longer and longer, and the arrows are getting longer and longer to the right. So they're getting longer to the right, they're adding on to the positive velocity to make for a positive acceleration because the speed is increasing. So if we want to draw our position versus time, we start at the origin, so we start at a position of 0, and then the slopes initially are going to be very, very small. It's not traveling as far per every unit of time, but as it moves on, the slopes will gradually get steeper and steeper, so we get our parabola. And because this is accelerating at a constant rate, the velocity is also changing at a constant rate. So since the velocity is changing at a constant rate, we will have a straight line starting at a velocity of 0 and increasing at a positive rate, which is why that will head up and to the right. And then number 2, we see that we're starting at an initial position of 50 centimeters this time and heading to the left down the ramp towards a position of 0. So if I want to call my 0 point on the left and 50 centimeters on the right, I'm starting at 50 centimeters and my velocity starts at 0, and then as it goes down the ramp, it will slowly begin to increase as it goes down the ramp towards the left. And its velocity is increasing as we're going from right to left. So as we're going right to left, that velocity has increased, and we see that the arrow lengths have also increased as well. So because we're starting at a position of 50, so we have a positive initial position, the position itself is decreasing because we're going from 50 towards 0. So our position is decreasing. Our velocity, because we're going right to left, we're going from 50 to 0, our velocity is negative. It is negative, but it is also increasing because we can see our arrow lengths are getting longer. We know that the velocity is going up. The velocity is increasing, so it is becoming more and more negative. And the acceleration, as we look at this, so the velocity is taking this object to the left, the marble to the left. The arrow lengths are increasing in length to the left, which means that the acceleration here must also be negative. And it's going to be negative because a negative acceleration put onto a negative velocity will cause that velocity to get increasingly negative. So now as we draw our position time graph, the object starts at an initial position of 50, So we have to start our graph up there. And initially, there's not a whole lot of change in velocity, so the slopes are going to be very, very small. And gradually, as this thing picks up speed, so its velocity gets more and more negative, we will see that as it begins, the slope is it's not changing a whole lot, and then it gets more and more negative, like so. Because these, and I'll even make that a little more dramatic, these slopes will begin to change faster and faster as this object begins to speed up. The slopes of the line is always negative, and it matches our velocity, which is always negative. The slopes are increasing at a negative constant rate, which means that our velocity will start at 0, and because the slopes of our lines are always negative and the slope is changing constantly, we will have a negative constant linear acceleration here. That is your practice for the marble ramp.